A Pandas data frame is a two-dimensional table similar to an Excel spreadsheet. A data frame has both a row index and a column index. A data frame can be seen as a concatenation of two or more series with the same index. Let's go to PyCharm and try to create a data frame out of two series. So we start here with our midterm and final series. We just gave them a name here. That name will be relevant in the data frame. And we're trying to concatenate them. The concat method takes a list of series. So we pass the midterm and the final series in the list. And let's see what we get here. This is not exactly what we wanted. The series were concatenated along the wrong axis. So the default axis for concat is axis 0. And when we concatenate the two series along axis 0, we get another series, not a data frame. So let's try something else. Let's concatenate the same two series, but along axis 1 this time. And this is a two-dimensional table. Let's see what its type is. And here's our data frame. Each series name was used as the corresponding column's header. So as we said before, a Pandas data frame is a two-dimensional table. Axis 0 is the row axis and axis 1 is the columns axis. The index of the data frame is the common index. To access an entry corresponding to a given index label, we use lock, just like we did for a data series. Now, to access a column, we use square brackets. Let's go to PyCharm for some examples. Let's say we want to access Dan's grades. So Dan is our index label. We write cs122.log of Dan. And the result is a data series that corresponds to Dan's row in the data frame. Now for the data series, we said that it's not recommended to use the square brackets directly to access an entry. With a data frame, it's much more than a recommendation. We get an exception if we do that. We must use log to access an entry corresponding to an index label in a data frame. Now, what if we wanted to access the data frame by column? What if we wanted the final grade for everyone? Here we use the square brackets. We specify the column name between the brackets. And the result is a data series. Now, what if we wanted to access Dan's final grade? Here we want to index both by row label and by column. We can do that. We have to specify lock, and then between the square brackets, we specify both the row label and the column name, separated by a comma. We can do the same using add. We can only use add to get a single value in a data frame. Lock is more general. Lock allows us to access several values. Lock may return a series, whereas add is only useful if I want to access a single value. And here's an example where I use log and get a data series. Here I want to access the final grade of both Dan and Anna. So I index by label from Dan till the end and by column final grade. And here I get a data series with the final grade of Dan and Anna. Note that we get a view here. Whenever we have a slice in Pandas, we have a view. We can remove a row from a data frame by using drop. Drop returns a new data frame with the specified row or column removed. Drop did not modify the original data frame here, but drop takes an optional parameter in place. When we set in place to true, the method returns none, and the original data frame is modified. To drop a column, we specify axis 1, and now the midterm grade column will be dropped in the resulting data frame. We did not use in place here. So the original data frame is unchanged. To add a row to a data frame, we do what we did with dictionaries. We simply assign a value to a given index label. We can also add a column by assigning a value to a new column name. There are many more useful things we can do with the data frame. We'll practice with a case study in our next lecture. In this class, we have talked about Pythonic code and how important it is to use certain idioms and follow the Python style guide PEP 8. With Pandas, we'll talk about Pandorable code. Writing Pandorable or idiomatic Pandas code is important for two reasons. The first reason is efficiency. Pandorable code is more efficient than non-Pandorable code. And the second reason is readability. Pandorable code is more readable than non-Pandorable code. So what is Pandorable and what is not? The first thing that is not Pandorable is chain indexing. Whenever you see back-to-back square brackets, that should raise a flag. That is not Pandorable. So we should not index by label and column back to back. We should not write lock of Dan and then final grade by chaining this indexing. We index by row here and then by column. This will work, but it's not Pandorable. We should never use this in our code. Instead of this, we can do this. We put both Dan and final grade within one set of square brackets and separate them with a comma. This has the same result. It's much more efficient and it's Pandorable. So no chain indexing in our code, please. Now method chaining, on the other hand, is good. We'll see a lot of it in Pandas, and using lambda expressions is also idiomatic in Pandas.